to another video. In this video we will be solving a LeetCode problem, that is valid Sudoku. We are given a 9x9 Sudoku board in this question, and we have to validate the position of all the elements in the Sudoku board, that is whether they are at the correct position or not. To handle this problem we will be using set. Let's start with the solution. First of all, we will initialize an empty set, then we will iterate over elements one by one over the grid. So for I in range, length of board, then for j in range, length of board, I. Now we will be iterating column wise and then row by row. First we will get the current value at the I and jth index, board I and j. Then we will create a string for the current row, current column and current cell. Say row is equal to current, so we have to convert the integer to string, plus number at row plus str of I. Then we will do same for the column. At column, this will be j. We will do the same for the cell block. Cell block refers to this 9 by 9 tile. Then number at cell score block. Then instead of str, j or I, we will be using the cells index. Str of j3. Let me expand the screen. Then we will check if board of I and j is not equal to dot. That is, we will first check whether the current element at the I and jth index an empty tile or not. Then if it is not empty, we will use the set hash set operation, that is whether the value exists in the set or not. Row in scene set, or call in scene underscore set, or cell underscore block in scene underscore set. We will return false. We will return false because this string is, any of this string is already present in the scene set, and that means the current element is already present in that row, column or the cell block. Else we will add the values to the scene set. Set add row, col and cell block. Then we will simply return true because all the rows were unique, rows, columns and cell blocks. So board, okay. Okay, this is not the modifiable set. Let me add the elements separately. Let's see if this gives any more errors. Let's submit the solution. Okay, our solution is accepted and the time complexity is big O of n square because we are iterating over the n cross n grid, and the space complexity is big O of n, that is all of the elements present inside the set.